Calipers. Calipers are used to make very precise measurements all the way out to the thousands place, if you really must know. So let's take a look at calipers in more detail. The scale at the top measures in inches. Okay, so here's the scale in red, and I circled the little inches unit there. We will never use this scale in methods. No inches. We will always be using metric. So ignore the top scale of the calipers. The scale on the bottom measures in centimeters. This is the scale you'll be using to measure in this course. However, please notice this little millimeter unit right over here. This implies that the units you are reading are in millimeters. This is incorrect. Always read this scale in centimeters. The scale down here is called the vernier scale. The vernier scale is what makes a caliper more precise than a ruler. And this is what you're going to learn how to use today. Here is a picture of the calipers when they are closed. Notice that the jaws, I call them jaws, I don't know really what they're called, are touching. When you want to move the jaws, your thumb should be on this round piece right here. Please practice moving the jaws back and forth. Please notice that the vernier scale moves when you move the jaws. This knob up here at the top is for locking the jaws and the vernier scale in place so that they do not move while you are taking your reading. So it's a good thing to practice. Give it a try, but be gentle, please, and don't take the knob all the way off. They're very easy to lose. And you don't have to tighten it really tight, just slightly tight with your fingers. Please close the calipers all the way right now. There is something else that you need to notice here, and it's super important that you understand this. When the calipers are closed, the 0 on the vernier scale lines up perfectly with the 0 on the centimeter scale. So those two lines line up. They appear to be one continuous line. Got that? Back up a little bit if you want to go through that again. This line, the 0 line on the vernier scale, is where you make your first measurement readings. That's the line you use. I like to imagine this line with an arrowhead pointing to where I need to read the centimeter scale. So let's try one. Find the 0 line on the vernier scale, right there. Now pretend it has an arrowhead and look to where that line is pointing on the centimeter scale. The whole number and the number in the tenths place are read from here. This is important to know. The arrow points somewhere between the 1 and 2 centimeter mark. So the whole number is 1 centimeter. The arrow is also pointing between the 1.2 and 1.3 centimeter marks. So far, your reading is 1.2 centimeters. Here's where the vernier scale comes in. The vernier scale allows you to read the measurements out to the hundredths and the thousandths places. That's pretty precise. Your final reading will then be 1.2 something something, and we need to figure out what those last two numbers are going to be. So here's how you do that. Start at the 0 line on the vernier scale, which is where that yellow arrow is. Moving from left to right, find the very first place where a vernier line matches up perfectly with a centimeter line. This is where people get confused. So let me show you what I mean. So you're looking for the first place where the vernier line perfectly matches up to a centimeter line in the scale above it. They will appear to be one straight line. So let's look at the first line. That does not line up with the line above it. How about the second one? Nope. The next one, that also does not line up. Nope. That doesn't line up with either of those lines. Again, no matching. No matching of lines. No matching of lines. No matching of lines. It's getting really repetitive. This almost matches. So I'm going to say this is the one that matches up. Do you see the difference between the one that says yes and the ones that say no? Yes, you can see that the two lines make one solid line. And that's the first time that happens. Okay? So, notice that the line on the vernier scale that matches up with the one on the centimeter scale is between the 7 and 8 on the vernier scale. If you could give this line a number on the vernier scale, what would it be? So take a guess. I would say 7.5 because it's between, or appears halfway between, the 7 and the 8. Now take the decimal point away. Remember, we already got the whole number and the number in the tenths place by looking at the 0 line. We read that as 1.2 something something centimeters. Now we can fill in the last two digits with the 7.5. 1.275 is the correct reading from this caliper. Notice that the reading has 3 decimal places. This is an important thing to remember. How would your reading be different if the lines matched on the 7 instead of between the 7 and the 8? Okay, so now we're just pretending, although the match is pretty close. You might say 1.27 centimeters instead of 1.275 centimeters. However, what's the most obvious difference between these two measurements? Hopefully you said that one measurement has 3 decimal places, whereas the other has 2. And that's important to keep in mind. The number of decimal places tells you about the precision of the instrument. The precision of an instrument does not change, but the numbers above imply that the precision did change because they don't have the same number of decimal places. So the precision of the caliper must remain constant from one measurement to the next, which means that the number of decimal places must be the same for both readings. You have to have them. Otherwise, they look like they came from the measurements came from different instruments because they have different numbers of decimal places. These calipers that we use in class must always be read out to 3 decimal places. Always, always, always. No exceptions to the rule. So, here's the question. What number can I put after the 7 that will not change the value of the number, but will give it a 3rd decimal place? What do you think? Well, we put a 7.5 on the line between the 7 and the 8. So we can just add a 0 after the 7 to give it a third decimal place. Now the numbers, the readings, the measurements will show the same level of precision. And you can see I have 1.275 versus 1.270. Same level of precision. Oops, I made a mistake right there. That should say 1.270. Do you see a pattern forming yet up in the drawing? Take a good guess. I put some more yellow marks on there. So what would be the measurement if the lines lined up at the 5? Between the 5 and 6, at the 6, and between the 6 and 7. So pause and take a few minutes and try to figure out what that reading would be, what those readings would be. So the first one, 1.250, because it's right on that 5 mark. If it's between the 5 and 6, it's going to be 1.255. If the measurement's right on the 6, if the lines line up right on the 6, we would call it 1.260. And if the lines lined up between the 6 and the 7, we would call it 1.265 centimeters. Notice that every single one of these has 3 decimal places. Okay, so notice that all of them go out to 3 decimal places. And they all have a 0 or a 5 for the last number. So the number in the thousandths place will always be either a 0 or a 5. So here's it sort of consolidated into one slide. Always read the caliper in centimeters. The whole number and the first decimal place are read where the 0 line on the vernier scale points. Then the second and third decimal place are read from the first place where a vernier scale line matches up perfectly with the centimeter scale line. That's the most confusing part. But go back in the tutorial and go through that again if you don't understand, or come and talk to your teacher. So if you can remember these facts, then you are almost the caliper master.